All right, welcome to distributed computing with a brief correlation to how it works a little bit in Hadoop. Distributed computing has been around for quite a while. It's kind of funny, I used to be a VMware instructor, and in VMware, we would take one real physical computer, right? And we would create virtual computers. We take one real computer and turn it into multiple pretend computers. And we call that virtualization. Distributed computing is almost the opposite. I'm going to take lots and lots and lots of real computers, make them work together, and pretend to be one virtual computer. All right? A big group of computers will work together, pretend to be one virtual computer. And that's really what distributed computing is. We're going to talk about distributed computing, what some of the different components are. Fundamentally, when we look at distributed computing, one of the common phrases you'll hear describing it is something called divide and conquer. Okay? We're going to take a job, we're going to slice and dice it into smaller pieces, and have different people go ahead and process those smaller pieces, and when we're done, go ahead and figure out what the results are. All right? Imagine that you had one of those 10,000 piece puzzles that all pieces, and you wanted to figure out how many pieces you had that had one nub, how many had two nubs, three nubs, and so forth with 10,000 pieces. And maybe at work in your team you have 5 people. Well, how do you handle that process? Well, ideally you get an intern to make him do all 10,000. Now, what we do, of course, is we say, okay, let's break this down into 5 chunks. All right, each of you go through and you analyze the puzzle pieces that you're given. And you go out, figure how many have one nub, two nub, three nub, and you keep your own little tally. And then when we're done, we're going to take the data from those 5 individuals, we're going to combine it to get our final results. All right? And that's one example of distributed computing. One of the most famous examples of distributed computing involves aliens. It's called SETI, the Search for Extraterrestrial Intelligence. It was called SETI at home. And what you could do on your computer is you could run a screensaver, and that screensaver, when you weren't using a computer, would kick in. It'd reach out to SETI's servers, and it would grab some data. It'd take that data back to your computer, and your computer would process it, analyze it, looking for unusual radio interference or whatnot that might indicate the presence of intelligence, and then it would return the results back. And people competed to see who could get the most blocks done. They had millions of people around the world, and that's a great positive example of distributed computing. Although it can be used in a negative manner. Sometimes if you want to attack a computer, you can do something called a denial of service attack, where instead of trying to open up a one page, your computer keeps trying to open hundreds of pages and try to slow the server down. Well, the most effective way to do a denial of service attack is known as a DDoS, a distributed denial of service attack, where they install some type of virus or worm on thousands or hundreds of thousands of computers, and then they all work as a team to go ahead and attack whatever particular computer. So distributed computing is powerful, whether used for good or evil, all right? Like my mom used to say, many hands make light work, which is true. Now, when we consider some of the basic components, the one thing we like about distributed computing is in the old days when we had one great big computer, and we would say, okay, we're going to have this great big computer go ahead and handle everything. Well, if we wanted to upgrade or get a little more power, the growth was really challenging, all right? What we're able to have with distributed computing is incremental growth. As I need more power, I simply add more nodes, all right, more individual small servers to my cluster, and I can linearly scale and gradually grow. The great thing is as it grows, something kind of neat happens. We start to go ahead, and one of the first things we'll notice is we'll start to have increased throughput. Because now we have more and more machines. Each of them are bringing their own network, their own compute, their own storage. So probably more IOPS, more gigabits per second on the network, and more of everything. We get increased throughput. Not only do we get increased throughput, we also get decreased response time. Because now we have more responders. And so as we grow, it actually improves more and more until we end up with just a crazy awesome system. Now you're like, okay, well, great, so I can add, but it seems like I'm adding that I'm going to have more and more points of failure. actually what's interesting in distributed computing is it has actually a very, very high reliability. Now, traditionally, when we think of reliability, all right, when we think of reliability, we think, okay, what's our mean time between failure and so forth. Well, that's really important. If that one computer fails and your system's down, that's a very accurate measurement, all right? But this is not one computer. It's an army of computers working as a single logical unit. And if one of them fails, the army marches on. And so you have incredibly high reliability. Now, out there, some people say, hey, go ahead and build these with the cheapest components you can get, because the overall system, so go ahead and use the cheapest compute nodes. It's usually not the best practice, because you're going to end up spending more time maintaining the system, replacing all those low-end compute nodes. But you want to find a nice balance. You can put a lot, you don't have to go super high-end. It has a lot of resiliency built into it. For example, you don't necessarily need to have individual servers running things like RAID 5 for disk protection, because in a lot of clusters and a lot of this distributed computing, that's actually built into the structure itself. And the last thing with distributed computing is when we compare it to go ahead and buying scaling up, buying a giant computer to go ahead and handle all this, compared to buying lots of computers to accomplish the same task, we're going to find this has a much better price. Okay, we're able to get much more compute power and throughput, and honestly, some of the throughput we get, we couldn't possibly get through a single machine. They're just not capable. Even if you went and bought a single computer, a super mainframe, you just can't go ahead and match it to 1,000, regular computers acting as a distributed computing cluster. And so these are very, very powerful. So distributed computing's been huge. One of the areas that it's really gotten attention is in big data. In big data, the one that is currently getting the most attention is Hadoop. So Hadoop has a couple different components. So let's go ahead and we'll put Hadoop down here. We know Hadoop is a big data. All right, so we have Hadoop. And one of the first components when you start talking about Hadoop is something called MapReduce. MapReduce for big data, or Hadoop, is literally a divide and conquer strategy. A bunch of data comes in, all right, and instead of having one computer try to go ahead and crank through all that data, we're going to take that data, break it up into blocks of data, maybe 128 megs each. We're going to ship it around throughout the cluster, all right, and they'll go ahead and they'll process that work that needs to be done. They'll go ahead and they'll do that job. When they're done with their job, they'll return the results. We can consolidate the results and get our final answer. Reduce the results and get that final answer. And it truly is, MapReduce is simply dividing a big job up and conquering it. And that's an example of using distributed computing. So from a compute perspective, that's really cool. But what about from a storage perspective? Well, Hadoop from a storage perspective uses something called the Hadoop file system, HDFS. The Hadoop file system is pretty neat what it does. Typically, our data is what we call worm, all right? Write once, read many times, all right? Write once, read many times is usually the way we store our big data. Well, Hadoop makes it very easy for us to do this. What it does is it goes ahead, and when a chunk of data comes into it, it doesn't make just one copy on one server, or even 2 copies on 2 servers. It actually makes 3 copies. So you actually end up 3 copies of the same data throughout your cluster, and it's all spread around to make sure if any one of them fails, all right, you're going to go ahead and it will automatically rebuild, detect a failure, you're still running. And so it allows you to have failures in your system, but still have your compute, the MapReduce, and your storage still fully functional. Another great benefit is now when you need a particular block, all right, I need 128 meg stripe, I can not only get it from one source, I can actually get it from 3 sources. And so if a particular file is broken up into 128 meg chunks, and they're scattered all over 100 different computers, all right, when I start requesting those blocks from the system, they can send a tremendous amount of data because I can have a lot of computers feeding me different blocks of the same file, all right, and really have incredibly high input-output. So what we're able to do in distributed computing, and like I said, one of the great examples of distributed computing, of course, Hadoop being a very popular solution for big data, allows to take a bunch of computers, regular computers, and effectively you turn them into one giant virtual computer. All right, one virtual supercomputer. They're all working together as a single cluster to accomplish the job of taking something that's really difficult for a single computer to do, break it down into small chunks, distribute it, and process it. So that's about it for distributed computing. Thank you for listening to this section.